That's a very important topic for Kadiska. I mean, retail is a strong focus we have. And one of the main reasons is that retail was one of the first one to digitalize their activities massively and change their infrastructure accordingly with quite a few performance challenges that we'll try to cover in this presentation. The first thing to understand is that moving to digital retail is a must for most retailers, and that's a matter of economic survival. There is a strong correlation between digitalizing retail operations and delivering shareholder value. So it's a matter of bottom line in the end. One that have digitized operations, there were more than three times the shareholder value. The people that automate processes in the store suffer 50% less from the turnover of their employees, which is a very important point for retail companies. And finally, when you look at the ones that first adopted cloud, SaaS, and edge optimized IT operations, they are more than one and a half time more efficient, and their inventory cost, as an example, is 15% less. There is a big economic challenge at stake when we think about digital retail, and that's important to keep that in mind. It's a must-have for any retailer. What does it mean? It means that the retail infrastructure is going to increase in complexity. So when you think of a store, any point of sales, you're going to find new things, new ways to interact with the customer, new operations, new processes that correspond also to new applications from an IT standpoint. So if you think of how we let us use self-services, cashiers, and information applications, how we let employees use web conferencing, how we provide Wi-Fi, how customer service and e-commerce is now fully integrated into the store operations, you understand that from an application standpoint, it has been a complete revamp. Pricing is also driven through applications. All the inventory is now real time, avoiding having to go through large inventory and having a lengthy and slow process for that. And a lot of retailers also use virtual desktop to allow that. The bottom line of that is twofold. Complexity has went up massively, and business performance really depends directly on the SaaS and the cloud application performance. And for that to work, they need low latency, always on connectivity to those cloud and SaaS platforms. How do they make that happen? That's another side of the transformation of digital retail. They know that they need great connectivity, great application performance. That's a key for having the right customer experience, having a good net promoter score, to have a good bottom line for each store. But the network that support this has to be different from the traditional network they had when they hosted most of their applications only in their data centers. And SD WAN is definitely a way for most retailers not only to be cost efficient from a WAN point of view, but also to reduce low latency and get the most of that transformation from a competitive point of view. So most of them move to SD WAN for cost, for redundancy, and for low latency, both to their data centers, to their clouds, and to all the third-party and SaaS services they're using and consuming from their stores. What are the challenges around that? Obviously, the first one is, as we have a straight relationship between application performance, network latency, and business efficiency, and the bottom line, retailers that have been through that transformation definitely need to have low latency connectivity, not only to their data centers, but also to cloud, to SaaS, and to third-party applications or services like payment, as an example. So that's the first challenge. Second is that the Wi-Fi in the stores has become increasingly important. If you start running your logistics based on Wi-Fi connectivity, if your customers consume your application through your Wi-Fi, the network and mobile application performance that you're getting through the Wi-Fi is also a very big point of attention and a driver of your business success. Communications that has changed because they are used between branches. Most advanced retailers will use collaboration suites. There are mobile devices or desktops from the stores to communicate and in real time between the branches and the headquarters. They will sometimes also use that to communicate with their customers and deliver customer service, as an example. And that has to work in an absolutely perfect way. All of the application has to be extremely responsive and provide the right digital experience. And this is true both for staff and customers. So on one end, You've got basic customers that are going to use applications both to consume the traditional e-commerce side of the business, but they are also going to use those applications inside the store to get information, to know about inventory, to look up for additional information about products. And the same is going to happen for most staff. All the things they had in the past will be passed through applications, and those have to be extremely responsive for people to execute their task efficiently. And finally, because all of the infrastructure that support the digitized retail has changed, the security infrastructure around it also has to change. As an example, a lot of digital retailers do not centralize traffic, tend to use CASBs from their retail stores or for their work from home employees. And that is also a challenge to be making sure this is working as good as possible. Why are those things challenges? The main reason this is a challenge is that all the tooling that was in place in the traditional IT side, so in data centers, things like NPM, APM, struggle to deliver the complete visibility on that. As an example, NPM were great at showing what was going through the data centers, but a lot of flows are not going through data centers. Another example is that APM struggle to adapt to new types of applications based on microservices, also failed to adapt to SaaS applications. And equally, all the internet flows and SD WAN performance is not well covered by NPM. So that leaves our most digitized retailers with gaps when it comes to monitoring SaaS and third-party services, when it comes to monitoring SD WAN to connect their stores both to their data centers, their cloud, and the SaaS applications. And they fill those pains both when they are in the run stage or in the migration, when they implement those new solutions. And finally, from a connectivity standpoint, those retailers get the feel that they have to monitor carefully how their on-premise environment is able to communicate with their clouds, or how their different clouds are able to communicate among each other, either because they combine SaaS and some cloud-based applications, or because simply they use different clouds for different types of systems, or because they've got different subsidiaries using different clouds, which in the end need to communicate. So what do we need to stay on top of that new infrastructure? The first thing is full network path performance. When you look at all retailers that have been through that transformation, the first thing that strikes our mind is a lot of public network are used either directly, for example, to connect customers to your applications, or to connect, stores to SaaS and third-party services, or to support SD-WAN connectivity, or to connect on-premise data centers and clouds. And looking at public networks requires a different approach than looking at purely private networks provided by a single operator. They are dynamic, they rely on multiple vendors, in most cases, multiple operators, and understanding not only whether the connectivity is good or bad, but understanding why it's changing in terms of performance, and what is the path which is taken, resulting into a good or bad experience, it becomes critical. The second one is what we call employee digital experience. So it's about understanding the performance of users, collaborators that connect to SaaS and cloud hosted applications or hybrid applications. And that requires a new way to look at it, because SaaS applications, for example, can't be instrumented like the old applications were. And still, as we use more applications into the business processes happening in store, well, it becomes more critical to understand exactly what is the performance that internal users are getting. Customer digital experience. So of course, when we think of it, we think of the old case for e-commerce performance. So obviously, e-commerce is more important than it has never ever been. But there are other applications that drive the customer experience, like the retail apps, the things that you use in store to design a kitchen, for example. I'll get back to that example, but a lot of retailers provide self-service stations in the stores or applications that the consumers are supported in their buying process. They also provide connectivity, which has an impact on that experience inside the store. And they've got to look at all the aspects of digital processes that support the customer experience. And finally, what you want in large retail organization is a rapid resolution. and proactive optimization. And that comes through having solutions that integrate easily into the existing tools that are in place and making sure that all the right IT teams get the right information in a timely way, which requires a lot of integration to what is pre-existing. If we have all of that in place, what are the benefits for the retail company? Obviously, you truly benefit from your transformation. You get the most of your network transformation and SD WAN, which means you save on costs, you get better performance than ever before, and you maintain fast performance issue resolution. So you keep your MTTR at a better place than it was before. The real outcome from a business point of view is that your employee remain productive, that you enhance your business performance, so you increase the top line on your stores, you avoid losing revenue because some applications supporting the buying process are not delivered as expected. And in the end, you win against the competition because your digital experience for the customer is better and you have a better bottom line. So if we have to illustrate this, I will take a concrete case which comes from one of our customers in Europe. It's a DIY provider focused on home improvement, gardening, decoration, and so on. It's a market leader in a single country where we started. They have 250 important stores overall. They're present in 15 countries. They've got about 30,000 employees. And they've been through the whole, or they are, to be accurate, they are going through a massive transformation at multiple levels. So they've been through a transformation of rehosting a lot of what used to be in the data center to a mix of SaaS and cloud hosted applications hosted in GCP. Obviously, all the new applications that come with new apps are developed straight into the cloud to become more efficient. And the structure of the connectivity between the store and those different applications has changed from an MPLS to an SD WAN, bringing more redundancy, lower latency, and of course a better cost. So what you see here is every store has got two underlays from different operators. Obviously, the Wi-Fi is modern and up to date. They still have some telco hubs where traffic is distributed, which allow on one end the access to the old data center, on the other end the access to GCP, which is their core cloud. They are still in the process of changing things when it comes to endpoints, when it comes to applications. A lot of applications are moving from traditional applications to mobile applications. And on the other end, in store, well, they're transforming their endpoint strategy from classical endpoints to mobile devices as well. What was the first challenge they came up with? The first thing is improving their SD WAN and SaaS application performance. I'll give you two examples of things they struggle with to illustrate the challenge. For example, when latency increased from the store to GCP, they struggle with one thing. Their SD-WAN was actually doing a good job, but they did not know exactly where the latency would be created between GCP, inside GCP, the operator that would stand between GCP and the telco hub, which hub they would go through, what security process is happening in the telco hub, at which impact, which operator they would go through as an underlay in the SD-WAN, and what part of the Wi-Fi would have in terms of impact. So the first thing was understanding where is latency created, which underlay is performing, and the objectives were clear. They wanted to have a better store connectivity, be able to optimize it, know exactly how to optimize their SD-WAN configuration. They wanted to reduce the incident impact on MTTR, and one of the first ways to do that was to know exactly in which segment, in the scope of which operator or vendor or team the problem would occur, and effectively work with vendors. So, for example, they found that when they had some underlay issues that would be a brownout, not a case of unavailability, operators would be very long to locate the case and understand, and that they would benefit from knowing precisely and being able to show objective data to their operators as to which router at which point is having latency, which is impacting their in-store operations and their SD-WAN performance. So the way they did that was by using the two hands of our solution, the user watcher, which is a real user monitoring extension placed on the browser of their users that monitors the the actual performance experience that their users are getting when they connect to SaaS applications or when they connect to their own applications. And that helps understanding first where there is a degradation, what is the scope, which stores are impacted to which applications doing which transaction, and which infrastructure layer is responsible. So is it a network issue? Is it a DNS issue? Is it a server processing issue? And then they deployed what we call net tracers, which are test stations from which we run DNS and connectivity tests to understand where we are being redirected, what is the path that we are following, what is the overall connectivity, and how to break down the connectivity and locate where there is an excessive latency generated or some packet loss being generated on the path. So this is deployed in the stores, in the hubs, and in the cloud. The outcome of that is an improved business performance. So they reduce the window of incidents that impact the business. They save turnover that way. They improve employee productivity in the end. And the MTTR has been reduced from weeks to hours when it comes to a performance incident. This is not precisely the case of one of our customers, which we can't show, but that will give you a good vision of what type of data you can get and how it can apply to retail operations. So what we see here is a list of applications we are monitoring. You see both internal applications like Kadiska platform and third-party applications, SaaS applications like the Google Suite or Notion or others. You always are able to follow which user, how many users use that application, what is the average time they use the application for. So that's over a period of 7 days that I've picked here. And the first thing from a performance standpoint is how good the connectivity is for the users to that application platform. So, for example, we can pinpoint right away that the connectivity to Google is really good. The connectivity to HubSpot, which is a CRM, is actually bad, which gives us the first information on how good or bad our infrastructure is doing, or how good or bad the infrastructure of the SaaS provider is for our customers. And then we are going to see experience metrics, either for traditional web applications where every time we interact with the application, we move from one page to another, those applications, or an API processing time, which is designed to be a good experience metrics for modern applications where you load a bundle and you don't switch page every time you run an action. You just run another API call, and that is reflected by the right data appearing in the UI. Like this application, as an example, is a good example of a single page application. And from there, I can understand also what drives the experience. Is it a redirection, so a proxy on the way? Is it a waiting time on the browser? Is it the network connectivity, so DNS and TCP latency? Is it the server, or is it the data transferred, like here for Google Docs, for example? The second thing I get is a vision of where users are and what performance they get. So here I see bubbles that tell me where I've got more or less users. I could actually map performance and see exactly where I get not so good performance. And I could filter on people that are remote or people that are on site. Okay. If I want to relate experience to where people are located and how they access applications, I can click here on user groups, get to see the same table, get to see the evolution of page load times, API processing calls, errors, big peak of errors, for example, here. And I can see that reflected on the map and be able to understand of my remote users, which ISP do they come from, what connectivity do they get, what experience do they get. And I can use that for ISPs. I could use that by country or region or city. And that's really designed for work from home users. And then I've got on-site users. So all the people that are connected to one of my sites or that are using my corporate connectivity, for example, things like a secured web gateway like Netscope or Zscaler. And I can understand right away how far they stand from a network point of view. For example, the Netscaler nodes stand much closer to the users than the Netscope, but and the experience is far better. And then I can see the different sites and see how it translates into an experience. For example, I can see the people from Toulouse having a relatively good performance, but still pretty bad experience due to the quantity of data they transfer. Or I could see that graphically and understand exactly how people make it to a certain application and understand the impact it has on their experience. And I can go down on that down to a single user. So for example, if I want to filter everything that Boris, Roger, and myself did, you can see right away what applications I've used, where I've had trouble connecting to one application. For example, my connectivity to SN has been tremendously bad at some point, and the experience was really bad. And there was a lot of waiting happening on my browser due to the calls not being processed fast enough. You can see all the different connectivity options I've used and the consequences they had on my experience. So, for example, Starlink is a far better option working from home for me than Orange. And that results into a significantly different set of response times, like 2 times. Okay. So all of that can be used for understanding plenty of applications. We can also focus on a SaaS application and be able to understand, to tell that SaaS provider where the connectivity to his platform is not as good as it should be, which transactions are happening enough or not so well enough, have too many errors, etc., etc. So that's one example. And to move to a connectivity side of the house, we can also find the connectivity both from an SD WAN point of view or to know exactly how we connect to a specific SaaS. So say that your operations team or your customer operations is using Salesforce as a CRM, just a few seconds, I can understand which part of the Salesforce platform is well accessible, not so well accessible, understand where in the world I've got stores with huge packet loss. Of course, if you've got stores in China, I would not recommend that you use Salesforce as a CRM simply because you will suffer from massive packet loss. And we can also see which part is not so well accessible or well accessible. So the more you turn into purple, the more latency you'll have, the more the red indicator is, the more packet loss you've got. So if I want, say, to focus on where I have got more packet loss, I'm going to be able to focus, for example, on northeast of the US and try to understand which of my stores are impacted by that. And I would see my list of stores and I would be able to see that, for example, my store in New Jersey is doing good. My store in Canada mostly are impacted by that. And if I want to understand, okay, how come I've got such packet loss, which will prevent my in-store users from using the solution, I will be able to see how that evolved for each of the stores, how latency also evolved, and I will be able to relate that to how each of my store reached the Salesforce service. And what you've got on the left is each of your stores. Every cycle that you've got here is a routing point that is being used, and each cycle here on the right is a different DNS resolution that you have for the same service. And as you see, through time, not all users are redirected to the same place. So if I take just a portion of that to simplify the vision, and I want to understand, for example, how the people from Montreal are exposed to packet loss and what I can do about it, and whether I can engage with my provider around that. I can see that people from Montreal in that day either used the global tech communications or connected straight to Hurricane Electrics, and that's where I had a lot of packet loss happening. If I want to see exactly what is being, which routes are impacted that way, I can see that whichever of my underlays I'm using, I'm going to be impacted by the loss happening in on that router from Hurricane Electrics. So for Montreal, the only thing I can do is call Hurricane Electric, which obviously is one of my underlay provider and has to fix that specific router, which is creating a lot of loss in that router as well. And that way I will accelerate the resolution and improve the access for my in-store users to Salesforce and fix my problem in a timely way.